How you always transfer from degrees to radians. Ready? All right, equals two fractions. How many degrees are in a circle? 360. How many radians are in a circle? 2 pi. How many degrees do we have? We've got 144 out of 360 degrees, and we want to know how many radians that is. Guys, remember how to solve a fraction equals a fraction problem? Cross multiply, yeah. So 360 times x is 360x equals 2 times 144 is 288 pi. Divide by 360 on both sides. You do not have to have a pi in your answer. You can just in your calculator right now take 288 pi divided by 360. Figure out what that angle is in radians. What was it? That makes sense. Okay, now that's not the answer to the question. That's just the angle, right? Now, do you know why that makes sense, that 2.51 makes sense for that angle? All right, everybody look up for a second, please. What is a flat line in degrees? 180. What's a flat line in radians? Pi, which decimal form is 3.14, right? And halfway, it's about half of 3.14, it's about 1.57. So 90 degrees is about 1.57, 180 degrees is about 3.14. It makes sense that this angle is about 2.51. That feels about right, okay? All right, so now we're gonna use that number, and we're gonna use this formula now. So now we've got S equals R times theta, but it has to be in radians, and we've got it in radians now. So S equals, what was it, 18.2 times 2.51. Put it in your calculator. I'll give you a copy of this. That one.
So this part is like really confusing. I don't know what.
An angle of elevation is how far when you look up. So it's this one down here.
So it's like.
No, it's an angle.
Oh, is this the one where it's like?
Yep.
Oh,
Okay. What'd you guys get? 45.68.
Yeah.
Okay. Any questions on how to use the arc length formula? Okay, I'm going to write AL next to example 1 and example 2 so that when you're looking back, you know that those were examples of arc length. Area of a sector is actually a really easy formula to understand. So maybe I'll do that on the side really quick. All right, what's the area of a circle? Pi r squared. Remember, you used to know that formula really well. So area equals pi r squared, right? But we only want a sector, and by sector I mean like a piece of the pie, okay? So we want like a portion of the circle, a piece of the pie. So if I want a piece of the pie, I have to find out what piece I want. So the whole circle is 2 pi, right? So I need to know what percent of that I want. And then I'm going to multiply it by pi r squared. And this percent is the angle actually, so I'll just put an angle sign up here. So what angle out of 2 pi times pi r squared. And do you see, look up, do you see how the pi's cancel out? So now we have area equals theta times 1/2 r squared, which is the area of a sector. Anyway, that's a quick little proof to explain why it is what it is. But it's very, very easy to use. Again, it has to be in radians, and I assume that you already know at this point how to do that. Let's find the area of the sector in example 1. Okay, so we're using the formula area equals 1/2 r squared times theta. So in your calculator, you're going to put in 1/2, or you could just put in 0.5, because you know 1/2 is 0.5, times parentheses 18.2 squared, or I guess you could just write 18.2 squared, times parentheses 3 pi divided by 8. Try putting that in your calculator. And see what that would be. If I'm color coding this, that would be this area here. That piece of the pie. What did you guys get? 195.11. Anybody else?
195.13.
All right, Kyle.
Good job, Kyle.
Remember that area is in centimeters squared, not just centimeters. That's more for length. All right, so let's talk about a real life application of this. All right, so let's say that you're looking at Reno, Nevada. It is due north of Los Angeles. In fact, if you're looking at latitudes, Reno is 40 degrees north. And Los Angeles is 34 degrees north. So the question is, how far is it between them? One is, if you look at the globe, one of them is right above the other. And that's the degrees different they are on the globe. So my question is this. Why are we trying to figure out, why are we using one of the formulas that we just came up with instead of just finding the distance between them? Yeah?
Because the world is round.
Because the world is round. Yeah.
So we need the sector.
Right, so instead it's actually like, it seems like a straight shot, right? It seems like a straight distance, but it's actually curved over the curvature of the Earth. Minusculely, but it is there. Like, it is significant enough. So we're going to draw a real quick picture. All right, let's imagine that, like, we're just looking at a part of the Earth. And let's see, 34 degrees. Here is Los Angeles. I was talking about Los Angeles with Penny for some reason.